Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over 4 worked examples to show you how to do problems involving specific latent heat. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get into it. Question 1 says to calculate the energy required to melt 500 grams of iron. Well, writing down what we know from the question here, we're trying to find the heat energy EH. We know that the mass M is 500 grams, which we need to change into kilograms. So dividing by 1000, this is the same as 0.5 kilograms. And what we now need to realise is that this question is to do with melting, which is also known as fusion. So because we're dealing with iron, we need to look at the latent heat of fusion value for iron from the datasheet. So we have LF for iron is equal to 2.67 times 10 to the 5 joules per kilogram, where F is just meaning fusion here. So writing down our equation for specific latent heat, we have EH equals ml, but I'm using ml subscript F here to mean fusion, just so we don't get confused with vaporization. So substituting in our numbers, we have 0.5 times 2.67 times 10 to the 5, and putting that into our calculator should give you an answer of 1.34 times 10 to the 5 joules. Question 2 says to calculate the energy required to change 3 kilograms of water into steam. Well, writing down what we know from the question, we're trying to find the heat energy EH. We know the mass M is 3 kilograms, but now we need to realise we've got water evaporating into steam, which is the same as vaporization. So writing down our value from the datasheet for the latent heat of vaporization for water, we have LV is equal to 22.6 times 10 to the 5 joules per kilogram. And again, that's on the datasheet. So writing down our equation, we have EH equals mLV this time, using V instead of F because we're dealing with vaporization this time. And substituting in our numbers, we have 3 times 22.6 times 10 to the 5. Putting that into your calculator should give you an answer of 6.78 times 10 to the 6 joules. Question 3 says that at 357 degrees Celsius, mercury boils into a vapour. If 20 grams of mercury can be vaporized with 5,880 joules of energy, what is the specific latent heat of vaporization of mercury? Well, writing down what we know from the question, we're trying to find LV, the latent heat of vaporization for mercury. I should point out you don't need to write the subscript of V here, you can just use L, but I think it helps keep you right with which values you should be using. So we also have heat energy EH is 5,880 joules. We have the mass is equal to 20 grams, which you need to change into kilograms. So divide that by 1000 to get 0.02 kilograms. And we can then write down our equation to get EH equals mLV. Rearranging for LV, we can divide both sides by M to get LV equals EH over M. Substituting in the numbers gives 5,880 divided by 0.02, which if you put into your calculator should give you an answer of 2.94 times 10 to the 5 joules per kilogram. Lastly, question 4 says that water in a kettle is brought to the boil at 100 degrees Celsius and then heated for a further 2 minutes, producing steam. The power rating of the kettle is 2.5 kilowatts. Part A says to calculate how much heat energy is added to the water during the 2 minutes. So writing down what we know from the question, we're trying to find EH, the heat energy. We know the power P is 2.5 kilowatts, which we need to change into watts. So that's the same as 2.5 times 10 to the 3 watts, or 2,500 watts. And the time is 2 minutes, but we need to change this into seconds, so we have 2 times 60 is 120 seconds. So writing down our equation relating E, P and T, we have P equals EH over T. Rearranging for the heat energy EH, we have EH equals P times T. And substituting in the numbers now, we have 2.5 times 10 to the 3 times 120, which gives us a value for the heat energy of 3 times 10 to the 5 joules. Part B then says to determine the mass of water converted to steam during this time. We're writing down what we know from the question, we're trying to find the mass M. We know the heat energy from part A is 3 times 10 to the 5 joules, and we need to think whether this is vaporization or fusion occurring here, where we've got water being evaporated into steam, so it's vaporization we're dealing with. So because it's water, we need to look up the datasheet for the latent heat of vaporization of water, which has a value of 22.6 times 10 to the 5 joules per kilogram. So writing down our equation, we have EH equals mLV. Rearranging for the mass M, we can divide both sides by LV to get M equals EH over LV. Substituting in the numbers gives 3 times 10 to the 5 divided by 22.6 times 10 to the 5. And putting that into our calculator should give you an answer of 0.13 kilograms. Lastly, part C says why would it take a longer time in practice to convert this mass of water to steam? Well, the reason for this is that heat is lost to the surroundings, and in parts A and B we assumed that all the energy from the kettle went into heating up the water and that no energy was lost. That's why we were able to use the same energy values in both. However, in practice, in real life, this wouldn't happen, and some of the heat would be lost to the surroundings of the room where it would heat up the air in the room instead. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.